Hi, my name's Dan. I work at a company called Cerbos, and I'm going to kick things off today with a bold claim. Most authorization systems in production today are fundamentally broken. That's because authorization and authentication are both pretty hard, and not just for you, right? They're hard and difficult for really big, well-known companies too. So for the next 20, 25 minutes or so, we're going to talk about why auth is the way it is today. We're going to look at some pretty magnificent failures, and we're going to go through some patterns to help you avoid becoming a magnificent failure of your own, or at least give you a fighting chance, right? So a little bit about me, because it's important to know where I'm coming from, understand my biases, right? I am a recovering system administrator. I've built and maintained large systems at places like Ubisoft and Mozilla. And I also worked at Datadog for quite a while, where I frequently ate lunch with the security folks. And that, of course, makes me an expert in operational security, as we all know. As I mentioned earlier, I happen to work for a little startup called Cerbos, and that will be relevant a little later on in this talk. Right now even. So what is Cerbos, right? Our official line is that we are an externalized policy-based runtime authorization solution for your applications. What that actually means is that we have like a little open source Go binary that exposes an API, and you feed it authorization policies, and it does the heavy lifting of making policy decisions. It's really deep into Kit, and if you want to talk more about that later, be super down, hit me up on LinkedIn, do whatever you need to do, right? All right, let's move on to the good stuff. Let's ask the big question, the $1 million question: what the heck is authorization? Right? Like, let's get that out of the way. And it's a really good question. I appreciate you asking it. Thank you. So authorization is fundamentally about answering a three-part question, right? Is this entity, or principal in the parlance, allowed to perform this action on this resource, right? It's related to, but separate from, authentication. Authentication is fundamentally about identities, right? Basically, who are you, right? Authorization is about permission, as in, now that your identity is established, what can you do with it? They're both extremely important. They're both related to each other. They both need to happen, and they don't always happen in the same way, at the same place, at the same time. And that creates some really interesting challenges, right? So let's start from the very beginning. We start with sort of the earliest days when we think about permissions. We think about POSIX permissions or POSIX permissions, right? So this idea of having a user group world model, and that you have this idea of having different sorts of roles or different sorts of contexts in which an identity can be placed. And then you have a set of primitives, which in this case are perhaps actions that can be performed: read, write, execute. And against what resources? Files, pipes, right, et cetera, et cetera. So this dates back again to the early days of Unix. And what's interesting about it is that although it is a model that is much older than most of us, right, it's the basis upon which a lot of authentication, a lot of authorization systems are still built today, as in built from scratch today. This idea of user group world read, write, execute. It's a very simple model. It's actually quite an effective one. But ultimately, POSIX has limitations, right? And the concept of access control lists, or ACLs, emerged in the 70s and the 80s, 1970s, 1980s, got to be clear about that now. And this offered a more granular level of control at the cost of additional administrative and implementation level burdens. And now this led to something called RBAC, role-based access control, in the 90s. And this was formalized by a paper, it was a landmark paper at the time, called the RBAC 96 proposal, became the RBAC 96 model. And it represented a more sophisticated approach, basically, one that could better model the way that businesses are actually structured, with some caveats. Now, this abstraction became the dominant enterprise model through the 90s and the 2000s, and it still underpins many of the modern systems that we have today. In fact, if you're using an authorization system today, there's a very good chance that it is based on RBAC. It's an RBAC-based system, all right? But we can fast forward now to today, right? Modern authorization has had to evolve fairly dramatically to handle cloud, microservices, distributed systems. So you got token-based approaches like JOT, JWT, pronounced JOT. They've become the standard for transferring authorization data between systems, while things like OIDC and OAuth have provided frameworks for federated authorization and authentication. But we've evolved beyond that simple perimeter-based security to a more layered approach where identity and context-driven authorization decisions are actually now sort of the way to go, the way forward, the state of the art. So rather than assuming trust once someone is inside the network, modern systems verify and authorize continuously across multiple trust boundaries. And these challenges apply to organizations of all sizes. So the architectural principles remain the same. They have always remained the same. But now we have to scale to handling a couple of requests a day up to billions of daily decisions. At the end of the day, it becomes the same fundamental problem. How do you do this in a secure, extensible, flexible fashion, right? So that's where we're at, right, with authorization today. It's a lot. It's big. It's kind of scary, and it's easy to get wrong, right? And in that spirit, let's look at some examples of where things went wrong, right? That's actually super important. So we're going to take a look here at this one. I want to make, actually, before we even get into this, I want to be very clear about this. I'm not dunking on anybody here, right? We're all allowed to make mistakes, and people do make mistakes. The important thing is that when mistakes get made, we learn from them. And the best way to learn about mistakes is to discuss them, to put them in the open, and share what we have learned about it, right? So again, not dunking on anybody here. So in May of 2018, Facebook, it was still called Facebook at the time, accidentally set 14 million users' private posts to public. They set them to public visibility during what should have been a limited test of a new feature inside of their system. The core issue was a UI change, so user interface change. It has nothing to do with post privacy or anything like that. It's a UI change. And this unexpectedly modified their policy enforcement layer, because their policy enforcement layer, which had to do with authorization, authentication, what was private, was public, was actually also the same as their UI layer. They weren't different. And by the time that they discovered and they fixed the bug, like 10 days later, millions of supposedly private posts had been publicly accessible. And this triggered significant privacy concerns, as you might imagine, and more troublingly for Facebook, significant regulatory scrutiny. Now, if you can think back to 2018 and you think back to what 2018 was like for Facebook, maybe this one got lost because a lot of stuff went on for Facebook in 2018, but this is one I think that's actually quite interesting. So this incident revealed three critical authorization and also authentication to a certain degree design flaws. First, a UI update inadvertently modified core policy enforcement logic. This is not a great look. And it shows how authorization decisions should really be isolated from interface level code. They should not be in the same place. They should not be the same thing. Second, the system lacked proper permission state validation before making those visibility changes. And third, there was no safeguard mechanism to detect unexpected permission changes. So those are three not very good things, right? All of this ultimately highlights why authorization logic should really be decoupled from application code at the end of the day, right? And I got some citations. So you see this at the bottom of a lot of my slides. If you want to take take a look at these papers for yourself, you don't have to believe just me. This is all publicly available information. So do take and do the research on this going forward. All right, enough dunking on Facebook. Let's move on to the next one. In October of 2023, Okta disclosed a breach where threat actors used good old-fashioned social engineering, right, to convince a third-party support company, contracted by Okta, to be clear, to send them HAR, HTTP archive files containing active session tokens. This allowed the attackers to effectively bypass authentication checks and gain support level access to customer environments. Now, again, I'm not dunking on anybody here, but what makes this incident particularly noteworthy is that it happened to a company whose core business is security and identity management. What I mean by that is this can happen to anyone, because again, auth can be tough, right? Now there's a lot going on in this incident, and I really encourage you to go and read the analyses that were done on it. There's a lot of very interesting stuff to come out of this. But as before, I want to focus on three things. First is their support system, which again was a third-party entity, and this support system had excessively permissive access to customer environments, excessively permissive. This violated a very important principle, the principle of least privilege, PLP, whereby users and systems should be granted only the minimum permissions necessary to perform their required functions. Nothing more than that, right? Second, there was insufficient isolation between the support tiers, which allowed broad lateral movement. Also not great. And third, their infrastructure relied much too heavily on session tokens in the first place. They didn't do any additional validation or any additional checks. Once you had a token, you were gold, right? And those tokens weren't particularly well monitored, and they weren't particularly well rotated either. And that's a theme we're going to see a little bit as well. So this incident shows why systems need multiple authorization boundaries, tiered access controls, and the like, especially for what should be privileged systems, right? All right, moving on. In January of 2024, so it's a bit more recent, Microsoft discovered and disclosed that a threat actor named Midnight Blizzard, also known as APT29, for those of you who know, you know, had compromised their environment. Now pay attention here, because this next sentence gets worse with every single word, okay? The breach began with a password spray attack against a legacy non-production test account that hadn't been configured with multi-factor authentication of any type. And this led to a severe breach at Microsoft. Again, I'm not dunking here, but what makes this incident particularly notable is that it involved Microsoft's own cloud environment. And this highlights that even the companies building our modern internet are not themselves immune to auth problems, right? So the Midnight Blizzard attack revealed critical authorization weaknesses in Microsoft's environment, unfortunately for them and unfortunately for everybody that was affected by it. First, excessive privileges in legacy tenant configurations gave accounts more access than was necessary. Second, inadequate tenant isolation allowed attackers to pivot from test to production environments. That's not great. And third, the lack of just-in-time access controls meant that permanent privileges, once compromised, could be exploited indefinitely. This incident demonstrates the importance, among other things, of reviewing authorization models continuously, especially for legacy systems, and implementing strong tenant isolation, especially for legacy systems, and also the importance, frankly, of dynamic privilege management, both at the authorization and authentication layers, which can be tricky for legacy systems. That's, again, why isolation is super, super important. So, okay, we've looked at three high-profile cases and a little bit about why those cases happened the way that they did, right? So let's talk about how to not be my next case study, right? Or at least give yourself a fighting chance, okay? So let's talk about token security. The token security is the cornerstone of modern distributed authorization. So to properly secure tokens, you got to focus on some critical practices, right? First, always validate cryptographic signatures. Do this to prevent tampering with the tokens themselves. Second, enforce strict and short expiry times. And this limits the blast radius of stolen tokens because your tokens are going to leak at some point, right? So you want to be able to limit the damage they can do. Third, verify that those tokens came from trusted issuers, which is related to but separate from verifying the cryptographic signatures, because you can have a cryptographically valid signature, it just came from someone you don't trust, right? In terms of storage, and storage is important, I would avoid client-side options like local storage if you can, which is sort of ironic because it's the most popular spot to put these tokens. There are other approaches. Let me know if you want to learn more about that. And the most common vulnerabilities that we see kind of in the wild are like weak signing keys, skipped validation checks, overly permissive CORS policies. That's a big one. And these are not theoretical risks. I'm not just sort of making stuff up here. These are real things. Token theft was, of course, central to the Okta breach that we just discussed, right? So next up is permission management, which is actually one of the biggest challenges in modern auth. The thing you got to watch out for here is role explosion, which is where you end up with hundreds of really poorly defined roles, permissions that nobody fully understands. Specific strategies to deal with role explosion will vary, but the contours of the solution generally involve role hierarchies, templates, dynamic RBAC, ABAC, things like that, right? The real path forward, in my opinion, is in fact ABAC, or attribute-based access control. There's a whole separate talk to be done about ABAC, which is outside of the scope of this one. We'll probably do it at another conference later this year, so keep your eye open for that. Other than that, just implementing, real-time or just-in-time access controls wherever you can. Checking things continuously, right? One check is not enough. Check things all the time, right? Grant elevated privileges only when you need to. Revoke them immediately afterwards, automatically afterwards when they aren't needed anymore, right? Super important. And finally, make least privilege a reality in your world, in your systems, in your infrastructure. The goal is a system where permissions are dynamic, where they're contextual. They're not static. They're not permanent. That's dangerous. And this speaks directly, again, the real world case here, to that over permissioning issue, to that lack of control issue that we saw in the Microsoft study, right? Also, for gosh sakes, get your authorization logic out of your application code. That's not where it belongs. The same goes for authentication logic. It should not be there, right? When auth logic is embedded in your code base, it becomes impossible to maintain over time. Trust me on this one, okay? Especially as the systems grow in size, especially as they grow in complexity. So by externalizing your auth, both Z and N, Z, I guess, do this across your infrastructure. And by doing so, you create a single source of truth for your basic policy decisions and your auth decisions across your entire system. And the separation delivers a ton of benefits, right? Including unified enforcement, regardless of which service is making the request, the ability to update policies without code deployments, the clearer audit trails for compliance and security reviews. That last part, of course, is going to make your CISO really happy, right? And again, this is not theoretical. This approach directly addresses authorization and consistency issues that we saw, for example, in the Facebook case, where UI changes, unexpectedly modified access control behavior, which shouldn't happen, right? There are a number of options in the space here. CNCF projects like OPA, which uses kind of an arcane Rego language to define rules. There's also Cerbos, which I work on, where you get open source, you get to define and write YAML policies. It's really good. Anyway, the goal is the same, right? Move authorization decisions and authentication decisions ultimately as well out of your application's code. They do not belong there. So let's talk about testing. This is definitely an area where hope's not a strategy, right? First, you got to implement policy unit tests that verify authorization decisions in various scenarios, especially including edge cases. Make those tests comprehensive, just like you do with your code, just like you do test-driven development with your code, do test-driven development with your auth, right? You need to cover both the allows and the denies. This is super, super important. Second, integrate authorization testing into your CI/CD pipeline, just like your code deployments, right? So that policy changes are vetted before they go to prod. Very, very important. Third, just like in configuration management, you need tests and tooling to detect drift, right? Config drift. The gap between the intended and actual permissions that sometimes emerges over time in production legacy systems, okay? This continuous validation is super clutch because modern authorization and authentication tends to be dynamic. And even with externalized solutions, unexpected behaviors emerge in complex systems. There's like a whole law that describes that, right? Authorization systems themselves Authorization systems present a unique challenge. They're on a critical path for almost every operation, yet they must remain highly available when enforcing strict security policies. Achieving high availability authorization requires, well, lots of infrastructure, or at least careful architecture, right? It's like local caching of authorization decisions, but then you get into questions about how should you cache them, how long should you cache them for, right? Fallback and failback policies for when services are unavailable. What happens when that occurs? How do you architect systems so that they are less likely to become available, et cetera, et cetera. Redundancy across multiple failure domains. How do you define failure domains? What do your perimeters look like? And now equally important are graceful degradation strategies, because at some point, something's going to go wrong no matter how well you architected it, right? And these graceful degradation strategies can maintain security even when components fail. Now, this might, for example, include a conservative default deny policy or a certain set of allow policies that allow limited access to something, right? You'll see tiered fallback rules based on risk levels. You actually see this a lot in fintech, right? Where it's like, we can access this level of a system, but not this level of a system based on what we can and can't understand about the context. You'll see circuit breakers for preventing cascading failures. Really, really interesting stuff. Anyways, the goal here is to ensure that authorization never becomes a spot for a single point of failure while still providing strong security guarantees. Anyway, authorization systems present what I think actually is a really unique challenge. They're on the critical path for almost every operation, yet they must remain highly available, enforcing those strict policies, right? And how do you get to that? You have to externalize your authorization decisions. That's just super, super important, right? You can't avoid doing it. And once you're able to externalize your authorization decisions, and ultimately your authentication ones as well, you automatically get to have a more cohesive, more coherent posture. And then from there, you can start to think about what can we do to harden everything else. And that's where things like rigorous validation and strategies around token maintenance come into play, and token management come into play. And then once you've got that on the front, what does it look like on the back, right? That's when you're going to talk about the real-time or just-in-time or immediate authorization decisions and authentication checks that happen repeatedly at multiple layers. And really thinking about that principle of least privilege when you're designing your backend systems, right? How are you actually using authentication and authorization systems to create more secure backend systems? And then once you've got all that, how are you ensuring that it is performing, behaving the way that you expect it to? And that's where testing, right, really, really comes into play. So test continuously, especially test your legacy systems. And if you can't test your legacy systems, figure out a way to test your legacy systems, right? That's super, super important. All right, so that's where we're at with authorization today. And again, it's big and it's kind of scary and it's easy to get wrong. And if you would like to implement secure externalized authorization that scales with your business, call me maybe, right? Check out cerbos.dev. I got a QR code right there. Thank you very much, everyone. Appreciate you. Bye-bye.